Infrared imaging, also known as thermography, is a non-destructive testing technique that utilizes infrared cameras to detect and visualize heat patterns emitted by electrical equipment. It is a valuable tool for predictive maintenance and troubleshooting, enabling early detection of potential electrical faults. Firstly, early fault detection. Infrared imaging can detect temperature anomalies, such as hot spots or cold spots, that indicate potential electrical faults. This allows proactive maintenance and prevents catastrophic failures. Secondly, non-contact measurement. Infrared cameras can measure temperatures remotely without direct contact with the equipment. This eliminates the need for shutdown or disassembly, minimizing downtime. Thirdly, comprehensive inspections. Infrared imaging provides a comprehensive view of an electrical system, allowing inspectors to quickly scan large areas for potential issues. Fourthly, safety. Infrared imaging eliminates the need for personnel to physically inspect dangerous or inaccessible areas, reducing safety risks. Infrared imaging can detect hotspots caused by overloaded circuits, which can lead to insulation breakdown. Loose connections create high resistance and result in temperature increases, making them visible using infrared imaging. Infrared imaging can detect the heat signature of arcing faults, which can be intermittent and difficult to diagnose using other methods. Infrared imaging can identify transformers that are running hotter than normal, indicating potential insulation or cooling issues. Infrared imaging can detect temperature increases around bearings, indicating potential lubrication problems or impending failure. Infrared imaging requires a trained operator to interpret the temperature data and identify potential issues accurately. Humidity, ambient temperature, and equipment load can affect the temperature patterns, requiring careful consideration during inspections. Infrared cameras must have a clear line of sight to the equipment under inspection. Sometimes, equipment disassembly or shielding removal may be necessary. Infrared imaging should be part of a comprehensive maintenance program. Detected anomalies require further investigation and corrective actions. Infrared imaging is a powerful tool for predictive maintenance and troubleshooting of electrical equipment. Its non-contact measurement capability, early fault detection potential, and comprehensive inspections enable proactive maintenance and prevention of catastrophic failures. However, proper training and consideration of environmental factors are crucial for accurate interpretation and effective use of infrared imaging. Overloaded circuits are one of the key applications that can be detected. When a circuit is overloaded, the conductors and components within that circuit begin to generate excessive heat. This heat is a direct result of the increased current flow exceeding the design capacity of the wiring or devices. The elevated temperatures can degrade insulation, weaken connections, and eventually lead to equipment failure or even fire. Infrared imaging provides a clear and immediate visual representation of these hotspots, allowing for prompt identification and correction of the overloaded circuit. Loose connections are another common electrical problem that can be effectively identified using infrared imaging. A loose connection increases the electrical resistance at that point in the circuit. This increased resistance causes electrical energy to be converted into heat as current flows through the loose connection. The resulting temperature rise is readily detectable with an infrared camera. Detecting and rectifying loose connections is crucial for preventing equipment malfunctions, reducing energy waste, and enhancing overall electrical system reliability. Arc faults, which are dangerous electrical discharges resulting from insulation breakdown or accidental contact between conductors, can also be identified using infrared imaging. Arc faults generate intense heat as electricity jumps across the gap, creating a localized hotspot. These hotspots are easily detected with infrared cameras, even when the arc fault is intermittent or difficult to observe with other methods. Detecting arc faults is particularly important as they can quickly escalate into fires or cause severe damage to electrical equipment. Infrared imaging is a valuable tool for locating and addressing these hazardous conditions. Overheating transformers can be a sign of underlying problems with the transformer's insulation, cooling system, or internal components. As a transformer operates, it naturally generates heat due to core losses and winding resistance. However, excessive heat can indicate that the transformer is not dissipating heat effectively or that there are internal faults causing increased energy losses. Infrared imaging allows for the detection of abnormal temperature patterns on the transformer's surface, which can pinpoint areas of concern and facilitate timely maintenance or repairs. Bearing failures in motors and other rotating equipment can also be identified using infrared imaging. Bearings are critical components that support rotating shafts and reduce friction. Over time, bearings can degrade due to wear, contamination, or lubrication issues. As a bearing begins to fail, friction increases, leading to a rise in temperature. Infrared imaging can detect this temperature increase, providing an early warning of potential bearing failure. Detecting bearing problems early can prevent costly downtime and equipment damage. It's also critical to consider the experience of the operator when using infrared imaging. Interpreting thermal images accurately requires a trained and experienced operator. The operator must be able to differentiate between normal temperature variations and true anomalies that indicate potential problems. They must also understand the factors that can influence temperature readings, such as ambient temperature, equipment load, and surface emissivity. Environmental conditions play a significant role in infrared imaging inspections. Humidity, ambient temperature, and equipment load can all affect the temperature patterns observed with an infrared camera. For example, high humidity can reduce the accuracy of temperature measurements, while changes in equipment load can cause temperature fluctuations. It is important to account for these factors when interpreting thermal images and assessing the condition of electrical equipment. Equipment accessibility is important because infrared cameras require a clear line of sight to the equipment being inspected. Obstructions such as enclosures, panels, or other equipment can block the camera's view and prevent accurate temperature measurements. In some cases, it may be necessary to remove shielding or disassemble equipment to gain access to the components of interest. Finally, follow-up actions are required after completing an infrared imaging inspection. The purpose of infrared imaging is to identify potential problems and facilitate proactive maintenance. When anomalies are detected, it is important to conduct further investigation to determine the root cause and implement corrective actions. This may involve performing additional testing, repairing or replacing damaged components, or adjusting equipment settings. A comprehensive maintenance program that includes regular infrared imaging inspections and follow-up actions can significantly improve the reliability and safety of electrical equipment. The effectiveness of infrared imaging and electrical maintenance hinges on several key factors. Understanding these factors is crucial for achieving accurate and reliable results. Emissivity is the measure of an object's ability to emit infrared radiation. Different materials have different emissivities, which means they emit varying amounts of infrared radiation at the same temperature. To obtain accurate temperature readings with an infrared camera, it's essential to know the emissivity of the materials being inspected. Some cameras allow you to adjust the emissivity setting to match the material, while others require the use of emissivity correction charts. Reflected temperature, also known as ambient temperature, can also affect infrared readings. Shiny or reflective surfaces can reflect infrared radiation from nearby objects, leading to inaccurate temperature measurements. It's important to be aware of potential sources of reflected radiation and to take steps to minimize their impact, such as using a matte surface or shielding the object from reflective sources. Spatial resolution refers to the smallest area that an infrared camera can accurately measure. A camera with higher spatial resolution can detect smaller temperature differences and provide more detailed thermal images. The spatial resolution required for a particular application depends on the size and distance of the objects being inspected. Distance to target affects the accuracy of infrared measurements. As the distance between the camera and the target increases, the measured temperature becomes less accurate. This is due to the fact that the infrared radiation emitted by the target is attenuated by the atmosphere. To compensate for this effect, it's important to use a camera with sufficient sensitivity and to keep the distance to the target as short as possible. Load conditions can significantly influence the temperature patterns of electrical equipment. The amount of current flowing through a circuit or the amount of power being consumed by a device directly affects the amount of heat generated. Therefore, it's important to inspect equipment under normal operating conditions to obtain representative temperature readings. Insulation can also affect the accuracy of infrared measurements. Insulation materials can block or distort infrared radiation, making it difficult to accurately measure the temperature of underlying components. In some cases, it may be necessary to remove insulation to obtain a clear view of the equipment being inspected. Scan rate refers to the speed at which an infrared camera can acquire and process thermal images. A camera with a higher scan rate can capture more images per second, which is important for detecting transient temperature changes or inspecting moving equipment. Image processing software plays a vital role in analyzing and interpreting infrared images. This software can be used to enhance image contrast, measure temperatures, and generate reports. It's important to choose software that is user-friendly and provides the features needed for the specific application. Calibration ensures that the infrared camera is providing accurate temperature readings. Regular calibration is essential to maintain the accuracy and reliability of infrared inspections. Calibration should be performed by a qualified technician using traceable standards. Documentation is essential for creating a record of the inspection results. This documentation should include thermal images, temperature measurements, and any observations or recommendations made by the inspector. Proper documentation can be used to track equipment performance over time and to identify potential problems before they become critical. The use of infrared windows can simplify inspections by allowing technicians to scan electrical equipment without removing panels or opening enclosures. Infrared windows are transparent to infrared radiation but opaque to visible light, providing a safe and convenient way to inspect energized equipment. Safety precautions must always be followed when performing infrared inspections of electrical equipment. Electrical hazards such as shock and arc flash can be present, so it's important to wear appropriate personal protective equipment and to follow established safety procedures.